Hello, and welcome to a Candid special of Le Chatelier's Principal at Work Thoughts Lab. So you guys went over this, and there was a few things that I wanted to hit on, just because I noticed that a few people missed it, and by a few I mean like a lot. All right, and then if you have any other questions, just let me know, and we can go over it together, or you can email me, or whichever you feel more comfortable with. All right, so the boys and girls at school dance seem to be okay. One of the ones that we did was the production of ammonia, and it asked you to include the heat term. And the only way you could do that is if you looked at the graph that was provided. Never mind, I can't draw that well. So I just pulled up the graph that was on the card, and you need to look at the temperature and how much is being produced at each. So if I look at this graph, I see that at 200 degrees Celsius, I'm producing a lot of ammonia. It's the highest it can possibly be. Whereas when I increase the temperature, the production of ammonia goes down. Okay? So when I do this, I know that high heat makes less ammonia. Okay, so when I'm writing out my equation, I have, sorry, my pen doesn't work very well. Okay, here we go with ammonia. When I increase the heat, I want less ammonia so that means that if I increase the heat, it's going to go over to the reactant side. Okay, so if heat, is on this side, and I increase the heat, then that means I'm going to shift to products, which is not what happens. So therefore, I know that this guy has to be exothermic, and heat has to be on the right side, because if I increase heat, then I'm going to shift to the reactants and make less NH3. And that's what my graph told me. Okay? So whenever you're looking at these, you have to keep in mind all the rules of Le Chatelier's principle, shifting left, shifting right, things like that. But then you also have to be able to use that information from the graph to get the information you need to put that together. All right? All right, next one. High temperatures, low temperatures. Once you guys got, you had the correct pattern, you just had to make sure that you had that this was exothermic. Okay? All right, water in the car, that one was good. In order to get water out of the car, you want to open the door and let the gas escape. If you want to keep water as a liquid, then you leave it shut and it gets moldy and gross, which is fantastic. All right, next one is production of ethanol. So with ethanol, you have sugar, and sugar can be broken down and created into alcohol, okay? Ethanol is the type of alcohol that is consumed by humans, okay? There are many types of alcohol: methanol, propanol, butanol, lots and lots of types of alcohol. It's just that ethanol happens to be the least dangerous for humans, and that's why it is out there for human consumption. All right, but make no mistake, ethanol and any alcohol will hurt you, and it does have some side effects, which you've probably seen if you watched like any TV show. All right, so we got some ethanol here. The nice thing about ethanol is this type of alcohol can actually be broken down very easily, so it's very good to put in our cars. So not only do we have gasoline at the pump, but you may have noticed that you have 10% ethanol, okay, or it'll say something like ethanol-free gasoline or something. And that's because when we put ethanol, alcohol burns very easily. It combusts very easily. So when we put that in our gasoline, it helps the gasoline to combust easily, and it helps reduce some of that waste that we don't like, carbon monoxide, carbon dioxide, those types of things, okay? It also means that we don't have to burn as much oil, and you know that oil comes from fossil fuels. And if oil comes from fossil fuels can't be renewed. So eventually, way down the line, we are going to run out of ethanol. Or not ethanol. We are going to run out of fossil fuels. Okay, we're going to run out of oils and gasoline and things like that. So the nice thing about this is ethanol is a renewable form of energy. I can make ethanol from many different types of substances, and it can help run our cars, but I can make it over and over and over again, and so therefore we can have fuel last a little bit longer, which makes it cheaper and cheaper for the consumer to buy, and therefore we can go do things. We can move around the country. We can go on vacation. We can, like truckers who bring all of the food to the stores, they don't have to pay as much, which means that we don't have to pay as much for all of our groceries. So it is a very good thing to have, and it's a very useful thing to have. All right, and then let's see, moving down. CO2 gas with CO2 aqueous. This one is important to know because whenever you put something in water, it's always an aqueous solution, okay? And when you have the gas likes to go out, okay? So if you increase the temperature, the gas is going to be able to escape because it has more energy to get out of the liquid, all right? And if you cool things down, it doesn't have as much energy, so then it can't actually get out of the soda or the liquid, okay? So being able to recognize Le Chatelier's principle, being able to shift left or right, but also recognizing the properties of the gas and the liquid, like how gases move faster, liquids move slower, so therefore, you know, they don't want to give up the gases easily. These are things that you can look at one problem and go into a few different chemical properties for. So that one was a good one to know. All right, last one. The one that I saw people having the hardest time on was 6 and 7 dealing with temperature. Okay, so on number 7, we have ammonia and oxygen make NO and H2O. Now, the thing is, the delta H is a positive number. Is a negative number. Why does that say positive? Hold on. Sorry. This is a negative. All right, so this guy is a negative number if you look at the actual worksheet over here. I don't know how that copied wrong, but that's okay. So we're going to have this guy as a negative. Negative means that it's exothermic, so that means heat is going to be on the product side. All right, and that's an E. Sorry about that, guys. I don't know. I think my pen is getting tired. Okay, so looking at this guy, when it says increase the temperature, you're increasing the products, so therefore you would need to make more reactants. Okay. I'm not sure what happened with these, but it was a common misconception when you had to put in your own heat term. So remember, heat, you just put it on the right side if it's exothermic, the left side if it's endothermic. All right. It behaves just like concentration. So if you increase it on one side, it's going to shift to the other side, and that's all you need to know. All right. So over here, well, that's nice. It put it over here for me. If you look, I have a delta H of 56.8, okay? And so this means that it's endothermic. So if I increase the temperature, it's going to shift over to the products. And then if I decrease the temperature, then it's going to make more reactants to fill that in, all right? So temperature was the one that I saw the biggest challenge on. But if there are anything else on here that you need to go over or have any questions about, just let me know. And I will see you for our review on Thursday.